Welcome to another episode of Coffee with Samso. Today I've got Richard Charlton here from ElectroAero talking to us about electronic propulsion. It's slightly off topic with the usual episodes that we do, but I think it's a fascinating one. Richard, thank you for giving me some time to have a little chat, and the flight that we just had, that was really interesting.
I'm glad you liked it, Noel, and welcome to our tech lab here at Jandakot Airport in Perth, which is actually one of the world's busiest small airports. It's a great environment to test out and fly the world's first production electric aircraft, which we can see behind us here.
It's extremely light too. I just saw you pushing it in for the shoot.
Well, that's right. It's made of carbon fibre, and I'm going to tell you a little bit about the history of this aircraft and how we've operated this the last 18 months. This aircraft is the Pipistrel Alpha Electro. It's designed and built by Pipistrel in Slovenia, and we're the world's first customer of the aircraft. We had it imported start of last year, and we had it registered and operating commercially from January 2018, which means we're actually the first company in the world to be able to offer paid flights in an electric aircraft. Now, this is interesting because in Australia we have world-leading aviation regulations regarding electric, and this aircraft is called a light sport aircraft, and we were able to take commercial instructional flights in this aircraft. So beginning in January last year, we had paying members of the public coming through and flying with our professional flying instructor. Since then, we've done 150 hours in this aircraft, making us not only the first but the most experienced owner of commercial electric aircraft in the world, right here in Perth.
Maybe we can start with just an intro of who you are and how all this sort of came about.
Josh and I are the co-founders of ElectroAero and first met in 2016. We were out flying in a bush airstrip out in the middle of nowhere, flying light aircraft for fun on the weekend. I'm a pilot, Josh is an enthusiast. And so we met by chance, and Josh told me that he had this plan to buy the world's first production electric aircraft. We got together and figured out how we could make a business out of it, how we could get it out there, how we could rack up experience flying this aircraft, because we were aware of these world-leading regulations that we have in Australia that would allow us to do this potentially years sooner than in Europe or the USA. We got this aircraft successfully in service at the start of last year, as I said, and since then we've learned a lot of lessons about operating electric aircraft day in, day out, commercial operations, pros and cons, how it's different from petrol. And it's been an incredible experience, and everybody who's flown this aircraft has loved it. Did you love it?
Yeah, no, it's different. I was just sitting there sort of thinking to myself, it's just strange, it's so simple. You know, I was watching you taxiing, and you turn the prop off.
Yeah, that's right.
Turn it back on again, you know. So yeah, it's definitely sort of an interesting thing. I remember when I first was introduced to you guys, it was a startup story. You guys were looking at sort of getting yourself out there. You're raising some money and things like that. I was really fascinated. I thought, geez, this is electric cars. Everyone's talking about electric cars. No one really. I haven't come across anyone who talks about electric planes. There's electric planes and there's electric propulsion, which runs the planes.
Yes.
You're not building planes, you're providing the engine for the plane.
That's right. So we're developing into an electric propulsion system company. Electric is coming for aviation. I mean, it's already here. Aviation tends to be a little more conservative than automotive in adopting new technologies. Pilots like myself tend to be conservative because we like to see that technology is proven and safe before we use it in aviation. But flying this electric aircraft has had me totally convinced, and without doubt, this is the start of the next revolution in aviation. Because when we think about it, the internal combustion engine is 120 years old now. We've been waiting a long time for a real revolution in propulsion. And that revolution is here now. So the Pipistrel Alpha Electro has over 100 orders. It's already in mass production in Slovenia. We started off operating this aircraft and building commercial experience, but our real business is developing and manufacturing propulsion systems. So Josh, my co-founder, he's an engineer with a background in drone technology. He used to run a drone company here in Perth with drones powered by ducted fans. And we realised together that we had this opportunity to power the next generation of light aircraft using electric ducted fans. So I'd take a minute and explain the technology here and why it's so relevant to electric, if you like.
Yeah.
If we look at a propeller aircraft, if the propeller is spinning, in simple terms, there's air being pushed backwards and there's air shooting off the side, okay? If you put a duct around the propeller, it captures the air that's shooting off the side, channels it backwards into extra thrust. So a ducted fan is the most efficient way of powering an aircraft. Every jet airliner in the world uses ducted fans, gas turbine powered ducted fans, and they have for many years. But it's never been possible on light aircraft before because piston engines are so large and heavy and complicated, they don't fit well inside a duct. But electric changes all that. So what we're doing now is developing electric ducted fans. See, an electric motor is very small, it can pump out a lot of power. So we can put that motor in a ducted fan, and you can see one behind us here, and then put that ducted fan anywhere on the aircraft. So it doesn't have to be in the nose like most light aircraft, because the reason engines are in the nose is because they're so heavy. You need to have the weight at the front. But a ducted fan is very light. Our ducted fans are carbon fibre. So you can put the duct anywhere on the aircraft, and then you can fill the plane with batteries, and voila, you've got the most effective and efficient propulsion system on light aircraft. And we feel this is the key technology to enable a whole new generation of light aircraft. So we're already working with a number of aircraft manufacturers to evolve their aircraft into ducted fan powered mass produced aircraft.
I can see, I remember when I first came and I see that you've got this like little lawnmower that's got ducted fans on it, really. Which is, I went, oh, that's when really, to tell you the honest truth, that's where it sort of clicked that it's all about the propulsion, and also it's about, once you got that part of it, really, as you said, it could be in any shape or form.
Exactly. So the oldest saying in aviation is that aircraft are designed around available engines. The engine is actually the most important part. Generally speaking, the engine comes first and then the aeroplane. Now we see in aviation this interesting situation. Companies either manufacture aeroplanes or engines, but almost never both. So even the biggest aircraft manufacturers in the world, so Airbus and Boeing, they buy their engines from a completely separate third-party company, which is typically Rolls-Royce or General Electric. And in light aircraft, it's the same. Typically it's Lycoming or Rotax, the legacy providers. So, because designing aircraft is hard enough in itself. It requires a whole set of expertise to design and build aircraft, and generally the engine technology is separate. So we started designing these ducts and doing consulting services, and from 2016 we had contracts with NASA. We were subcontracting on the NASA X-57 electric aircraft project. We sold some prototypes to Bell Helicopter in the US and a number of other companies as well. And we realised quickly that what these companies want, it's not just a ducted fan, it's the whole propulsion system, right? It's the whole thing that basically would turn up in a box at the aircraft manufacturer's factory, bolt it on, plug it in, off it goes to the customer. So we're talking about the ducted fan, the propeller, the motor, the speed controller, batteries, airworthy battery housings, the throttle, pilot interface, avionics, control systems, and all the software that runs it, and the superchargers to charge the batteries. So we're actually developing all of that technology as a complete, what we call end-to-end turnkey propulsion system that can be provided to aircraft manufacturers and designers.
Are you guys restricted to aeroplanes?
Look, right now we're focused on aircraft. It's such a specialised and demanding area because aircraft components, they have to be extremely reliable, they have to be weather resistant, and they have to be light. Okay, so you've got some contradictory goals in aircraft. So we're specialising in aircraft, but our ducted fan designs could in theory power a range of other vehicles, and that's certainly an option that we keep open. At the moment, we can't disclose the manufacturers that we're working with, so we can't show you shots of some of the specific aircraft that we're evolving into electric versions, but you can see some of our technology, such as the individual ducts here.
I mean, I've got a pretty good imagination. I can picture where this could go, but I'm sure you being in the industry, you guys are probably, years ahead, or in terms of what you could fit your propulsions for. I mean, I remember we had a discussion. I said, "Oh, look, obviously before I met you the first time, I spoke to some people who have, some flyers and things like that. They would say, oh, electric planes or electric engines. You have this issue with lithium batteries because they can blow up,
like petrol, right?"
Yeah.
Petrol is explosive and flammable. We've been using it safely in aviation for years. So lithium batteries, same. We're developing safe ways of using them in aviation. The key question people usually ask first up is, well, how long does the batteries last for? Okay, and I have good news on that front. With current technology, batteries, and we're using, in our first projects, we're using current in production battery cells because they're low risk, because we know exactly their properties, they're already mass production to a standard and so on. So we're using proven battery cells. We can achieve between 1 to 3 hours of flight endurance, depending on the mission profile of the aircraft and customer options. So that's 1 to 3 hours with current battery technology, and there is scope for lithium power density to increase dramatically. Some predictions are we could see up to a doubling of density in the next 5 years. So we'd be opening up 5 to 6 hour endurance, which is enough to cover 99% of light aircraft missions. So the short answer is we've got enough endurance, even with current technology, and this is made possible by the ducted fans. Because you stick a ducted fan on an aircraft, that aircraft is properly designed, you're getting anywhere from 30 to 50% more endurance out of the same batteries because of the extra efficiency from the ducted fan. Okay, that's why we think it's such a key technology.
Yeah. Just off topic, this coffee is actually nice. I know you were professing how great it was. As we were flying, I mean, one of the topics that I was thinking in my head was, this kind of planes would very suited to maybe farmers or people who are in sort of the country.
Do you know what? I reckon it's best suited to really busy training schools in big cities like Perth, because the number one problem that airports have all over the world, it's noise. It's noise. You talk to airport operators, they go noise, noise, noise. They have time of day restrictions, they have runway restrictions, they have altitude restrictions, they have curfews, they can't accept certain aircraft that are too loud and so on. Now, electric completely solves this problem. So the Pipistrel Alpha Electro here, we had some sound engineers come and measure the sound levels at 1,000 feet above ground level in the circuit area around Jandakot. So 1,000 feet is the lowest that aircraft can legally fly over populated areas, right? So you can hear Cessnas and light aircraft very, very clearly from 1,000 feet, even if they're going slowly and low power, it's very loud. Our aircraft here, indistinguishable from background noise at 1,000 feet, okay? So that means it's effectively silent at 1,000 feet above ground. That's revolutionary for the whole industry. It enables tons and tons of new possibilities for aviation. Short-range air taxis, flying training all day and all night, overpopulated areas, around busy airports. So we feel that the first adopters of this technology may well be professional flying schools. Because not only are you getting, with electric, of course, you're not just getting quieter, but you're getting cleaner, which is also a major issue in aviation. Because by the way, 95% of light aircraft today run on leaded fuel. It's leaded fuel developed in the 1940s. It's nasty. It's nasty stuff. Okay, avgas. It's powerful fuel. It's only produced these days. Leaded fuel is only produced for aviation these days. It's very expensive to produce. We want to get rid of avgas, but it's going to require all new aircraft with new propulsion systems. So that electric, it's done away with. Zero emissions, virtually zero noise, and arguably the best part for the businesses is that it's exponentially cheaper to fly. Okay, exponentially cheaper in terms of direct energy costs and maintenance, because an electric motor has one moving part compared to hundreds in a piston engine. So with all these benefits, noise, pollution, cost, maintenance, not to mention simplicity, like you say, it's really simple to operate. We would see that maybe flying training schools and enthusiast private owners would be the first adopters.
Do you see a role there for hydrogen fuel, electric fuel? Can they work together or are they separate entities?
It's a good question. And ultimately, hydrogen is a way of charging batteries. So hydrogen fuel cell, it's like having an onboard battery charger. So there's no reason at all that you couldn't combine battery electric powered aircraft with lithium batteries with hydrogen fuel cells on board. Potentially could be lighter aircraft and potentially could be longer range. We can't predict for sure whether that might happen or might not happen, but for us it doesn't matter, we welcome it either way. The issue with hydrogen is it has a complex supply chain. So like gasoline, it requires a lot of movement to be transported from source of origin to processing to end user. Whereas with electric, we're charging off solar panels off the roof of the hangar. So we can generate the electricity within 10 meters of the actual aircraft. In theory, pure battery electric is simpler and potentially cleaner for the environment if it's local generated through renewables. Look, we're growing very fast, and with 12 staff now on board, we've got some quite well-known investors on board as well. So Dr. David Warren, one of the co-founders of Altium Limited, is one of our major shareholders. He built and flew the first electric aircraft in Australia a few years ago. He's also built electric speedboat. So he understands the technology very, very well, and he backs us completely in terms of the strategy that we're doing to focus on the propulsion systems as a supplier of choice to the industry worldwide. Because aviation is a global business. From here in Perth, we can supply the entire world. You know, we have a world-leading reputation for safety and quality in Australia in aviation. We already have a number of manufacturing organisations in Australia, and they will be eventually manufacturing our systems. So we're the technology design house, prototyping and development house. The actual manufacturing will be done by certified manufacturers to enter mass production. And we can have some of our systems on in-production aircraft as early as next year being mass produced and exported to other markets, mainly China.
I mean, look, you know, problem with Perth is that we get pigeonholed into a back country, but when you talk about kind of technology that you guys have in the business model that you guys have, I mean, you're a worldwide kind of thing, international. You know, you can go a long way, but people just think, oh, Perth, you know.
That's a bit unfair, isn't it? Because the engineers that we hired here, most of them are graduates from the local universities. They're very highly qualified and experienced engineers. We've got world-leading flight training facilities here. We've got professional flying schools at Jandakot. We've got the world's best weather.
Right, yeah.
Okay, we've got the world's best weather for flying training. We've got excellent airspace and fantastic infrastructure and transport links. So we're only a short hop away from the rest of the world, and we're in the same time zone as Asia, as people keep telling me. So in fact, we're in the right place at the right time with our leading regulations in Australia to actually become potentially major player in propulsion systems. It's funny, it often takes a startup player to shake up the industry. China Southern and Singapore Airlines both have their pilot training schools here at Jandakot, as well as the world's largest flying doctor base and West Australian Police and a number of other clubs. So it's a very busy airport, and again, it's a great place to actually test and develop electric aviation in this environment. Busy professional environment. We do the ground testing for our systems, and then we ship to the manufacturers for them to do flight testing and certification.
And the first time I met you guys, I heard the story, I was sold. I think it's just something that you don't expect out of, you know, Perth, but I think you guys are on the right track. I mean, the model that you guys got, you're actually, you know, not burning cash, but you actually got contracts on that you're actually fulfilling. You know, so that's different. That's why I felt that you guys are slightly different to you're not a concept thing. You're already making, building, and proof of concepts already done.
Yeah, that's right.
You know, so you're way down the road, which is again, you know, everyone when I mention things like this, it's you don't expect it to come out of Perth. But I think those days will probably be behind you guys, definitely. I mean,
I like to say in aviation that the history of aviation, it's not necessarily about what's technically possible, it's about what's financially and politically feasible. Okay, if it was just about technology, we'd all be flying supersonic airliners, but they're just too expensive. So what we do here is develop cost-effective, safe propulsion systems to enable all the aircraft designers out there to design new electric aircraft. So at last count, there were over 200 startup companies around the world designing clean sheet, brand new electric aircraft. Now they all need propulsion systems. And on top of that, you've got established manufacturers who want to offer electric. They want to evolve their aircraft into electric, from petrol to electric, on current in-production models. And again, we want to help them solve that problem. We want to do it in a way that's financially feasible and safe and efficient. So we think the time is now for the revolution.
Look, I have a saying in the mining industry: everyone wants to be a Paddy Hannon. There's nothing wrong with supplying donkeys, salt, pepper, and shovels to them.
That's right. Now, my great-grandfather actually sold shovels in the Ballarat Gold Rush back in the 19th century. And I think in the same way, we are kind of selling the shovels to this new industry today.
No, that's perfect. All right, Richard, thank you. Again, hopefully we can follow your story a bit, and that later down the road we can have an update down the road.
Look forward to it. Thank you.
Thank you.